Good morning, my dear students. Today I am going to discuss under organic chemistry the next unit haloalkanes and haloarenes. Haloalkanes and haloarenes. One is haloalkane, aliphatic, haloarenes, aromatic. I am Dr.R.G, Professor of Chemistry, who is taking class for you. Under the haloalkanes and haloarenes, what are the topics I am going to discuss today? Generally, in all organic chemistry, compounds, classification of compounds, this is the order. Normally, the first will be test for functional group. Test for functional group is the first one. And second, classification. Third, nomenclature. Fourth, isomerism, preparation, properties and uses. Why I specifically left here the test for functional group? Because I have discussed under the classification of organic compound all the tests I have discussed. So kindly verify from that unit. You can verify for the functional group of halogens. So just if you want, I will just remind you. So any sodium halide, kindly follow. Any organic halide, when you treat with aqueous sodium hydroxide, strongly boil, it will be converted into alcohol and sodium halide will be forming. So this sodium halide, so the halogen from the organic compound which is in the form of covalent bond, now converted into ionic sodium halide. Now to this, if you add dilute nitric acid, boil and then add silver nitrate, you will get a precipitate, characteristic precipitate. So kindly follow. In the case of halogens, white precipitate, freely soluble ammonium hydroxide, chloride. Pale yellow precipitates, sparingly soluble, bromide. Yellow precipitate, insoluble, it is the iodide. So this is the way we have to test for the halogen. Okay, let me concentrate. Classification, nomenclature, isomerism, preparation, properties and uses of haloalkanes. Kindly follow the first today. So how we have to classify? Whenever you want to classify, so we will classify broadly into two types. One is aliphatic, another is aromatic. Aliphatic means normal open chain. Aromatic means there will be a benzene ring will be present there. And the difference between aliphatic and aromatic, we have already discussed the two conditions. One is to be aromatic, what are the conditions? Also I have discussed. The test for differentiating aliphatic aromatic also I have discussed under the hydrocarbon. The same test you can apply for all the types of compound. No, I need not repeat again. Kindly you can check up from hydrocarbon. Now aliphatic, further I can classify into two types: open chain aliphatic, closed chain aliphatic. And open chain I can classify saturated and unsaturated. Same way aromatic, aryl, that is only aromatic ring and halogen directly connected. Alkyl means it is benzyl chloride. This is the difference. Alkyl, this is aryl. Kindly follow. Let me go for now. Let me take one by one now. First classification, halides, aliphatic and aromatic. Specific example, here 6 carbon atom, 1 chlorohexane. I simply say chlorohexane. The other side, it is there chlorobenzene, aromatic. So specific example. Now coming for aliphatic, I already informed you open chain and closed chain. Open chain, chlorohexane. The closed chain, chlorocyclohexane. Chlorocyclohexane. Please follow. Hexane open chain. Here cyclohexane is the primary prefix, secondary prefix chloro. So chloro cyclohexane. That is example of closed chain. Now open chain, I can further classify into two types. One is unsaturated, another is unsaturated. Saturated, again chlorohexane. One chlorohexane. Here automatically this is 1, this is 2, 3, 4, 5, 6. So this is nothing but one hexane. So one chloro, one hexane. Kindly follow. This is the example of one chloro, one hexene is an unsaturated compound. Coming for saturated open chain compounds, again we can classify a number of ways. One is only one functional group, saturated. Say example, methyl chloride, ethyl chloride, etc. With more than one functional group, say for example, two functional group, dichloromethane, 3, the halogen atom, chloroform, 4, carbon tetrachloride. Please follow. So, this is the specific example you must know. Coming for unsaturated examples, this is called vinyl chloride, common name. Ethene, one, that is 1-chloroethene. The corresponding this compound, kindly follow. This is allyl chloride, common name. Kindly follow. So this is commonly used, vinyl, allyl, 3 carbon atom allyl, 2 carbon atom vinyl. Please remember these terms. So coming for haloarenes, aryl halide chlorobenzene. I have already shown the structure. The alkyl halide benzyl chloride. Benzyl, there is side chain and then chlorine. So this is aromatic side, this is aliphatic side. So alkyl halide, this is benzyl chloride, common name. Please follow. Now, so that is the classification I have discussed. The second topic is nomenclature, naming. We know I have already discussed under the nomenclature, when I was discussing in the basic concept of organic chemistry, I have given very clear idea. So nomenclature we can classify into common name, another is IUPAC. Please follow. Common name we have classified into 3 types, 1, 2, 3. The first one, based on the nature of the source. Animal, plant, like that. If it is coming from man, like that, we will give the common name. Simple example from ant, that is formic acid, formica example. The second example is, it is applicable only when there is a functional group. So automatically here there is a functional group, halogen is there, so that based on the position we can give the common name. Kindly follow. And the third is, second one is based on the chain, carbon chain. That is normal chain, iso and neo. This is the second method. Please follow. First method from source, and from the nature of the chain, second method, N, iso, neo. Everything we are going to discuss, I am giving introduction. Third method is based on the position of the functional group attached to carbon. We have classified into primary, secondary and tertiary. Please follow. Now let me take the first common name. The common name here is methyl chloride, ethyl chloride, chloroform, carbon tetrachloride. These are all common names based on the source or other way. Now, common name based on the chain, kindly follow. Based on the chain arrangement, I am giving common name. If it is a normal linear chain, it's a N, total number is 5. So N pentyl chloride, normal pentyl chloride. And another one here it is, kindly follow from this carbon 1, 2, 3, 4, that is butane. This is 5 correspondingly. So methyl group attached to second carbon atom. So I am using iso. So if the second carbon atom is attached to methyl group either from left or from right, we'll call it as iso. So this is isopentane corresponding chloride, isopentyl chloride. The third one is neopentyl chloride. Kindly follow. Here it is 2 methyl groups attached to second carbon atom. So this is the linear chain. 1, 2, 3. So this is neopentyl chloride. Please follow. So commonly how the question will be asked, what is the IUPAC name for neopentyl chloride? What is the IUPAC name for isopentyl chloride? If it is asked, you have to first write the structure. Then you have to follow the IUPAC name and you have to give the IUPAC name. Kindly follow. Now, the third type, based on the position of the functional group. Kindly follow. Based on the position of functional group, we can classify the third type, common name. One is, kindly follow, this is primary butyl chloride. Primary butyl chloride. What is primary butyl? So this chlorine, there are 4 carbons, so butane parent. First carbon is attached to chlorine, is again attached to only 1 carbon, so it is called primary. So in this case, we are calling it as secondary butyl chloride. There are 4 carbon, but here chlorine is attached to a carbon, which is attached to 2 other carbon. So we are using secondary butyl chloride. Purely depending upon the carbon having the functional group. If it is attached to only 1 carbon primary, 2 carbon secondary, 3 carbon tertiary. So tertiary butyl chloride, so here attached to this carbon attached to 3 other carbon. Kindly follow. So this is tertiary butyl chloride. This you can apply for other thing also, alcohol also. Primary butyl alcohol, secondary butyl alcohol, tertiary butyl alcohol. Amine also, primary butyl amine, secondary butyl amine, tertiary butyl amine. So, based on the position of the functional group, we can use primary, secondary and tertiary. Kindly follow. So again, question can be asked, what is the correct IUPAC now? Name for tertiary butyl chloride. Please follow. So now common name I have completed. Coming for IUPAC, it is containing 1 halogen, 1 chlorine atom, which is the functional group. So halogen may be chlorine, bromine and iodine. So commonly we are taking chlorine here, so I am using chlorine. So I have already classified you when I was discussing basic concept of chemistry. The entire organic compound can be classified into 3 types. Please follow types. This is according to me, not given any other book. Please follow. Not given any other book, only according to my experience, I am classifying this. The first one is compounds containing without any functional group, only alkane. Only alkanes. Then here, second one, compounds containing 1 functional group. 1 functional group, that is second type. Third is more than 1 functional group. More than 1 functional group. That is type 3. So here 1 chlorine atom is present, methyl chloride. Kindly follow. I am giving IUPAC name for this one. Common name methyl chloride, 1 chloromethane, 1 chloroethane. Kindly follow. Now there are 3 chlorine atoms are present here, attached to the same carbon. So this I will call it as, according to IUPAC, 1, 1, 1 trichloromethane. That is chloroform common name. The same way, carbon tetrachloride, CCl4 is the common name, IUPAC name, 1, 1, 1, 1 tetrachloromethane. It is a IUPAC name. Please follow. So, now let me go for the next unit topic, isomerism. Please follow. What is isomerism? Compounds having same molecular formula but different physical and chemical properties are called isomers, and the phenomenon exhibited by these isomers is called isomerism. So we can broadly classify: one is structural isomerism, stereo, structural of 4 types. One is chain, positional, functional group, metamerism. Then stereo 2 types, optical and geometrical. Totally 6 isomerism are possible in the any organic compound. And depending upon the nature, some will be missing, some may be present. So in the case of haloalkane, what are the isomerism? Possible isomerism, the not possible isomerism. Kindly follow. Chain isomerism is possible. Dear students, kindly have it in mind. Chain and optical always present in all types of organic compound without any exception. So out of 6, 2 is very clear, always present. Then positional isomerism is possible in the case of the haloalkane. So 1 chloro, 2 chloro, 3 chloro, like this. So what are the groups, the isomerism not possible? Functional group isomerism not possible, because it has to form 2 different functional groups. So for example, if we take ethyl alcohol, kindly follow, and correspondingly dimethyl ether, you have the dimethyl ether you have to take. So this is the functional group isomerism. So when it is only chlorine atom, so functional group not possible. Metamerism, again, it is not possible in the case of haloalkane. Geometrical isomerism is possible only in the case of alkene and their derivatives. So I will concentrate only possible isomerism with a suitable example. Kindly follow. Chain isomerism. Kindly follow. Normal chain, iso chain. We already know. Normal iso. So in the name of IPC, I am giving here 1-chlorobutane. This is example. Another is 1, 2, 3. So 1-chloro-2-methyl propane. These 2 are examples of chain isomerism. Kindly follow. Because one is linear chain, another is branched chain. Kindly follow. Always the first carbon atom here also 1, 2, 3, 4. So only in the first carbon atom chlorine is present. So what is the difference in arrangement? Here linear 3 carbon atom, here it is the isopropyl group. Kindly follow. That's why it is called 1-chloro-2-methyl propane. So these are examples of chain isomerism. Kindly follow. Then positional isomerism. I told you change of the number. This is butane, 4 carbon atom, 1-chlorobutane. Carbon 1, 2, 3, 4. This is 1, 2, 3, 4. This is 2-chlorobutane. So positional isomerism having 1-chlorobutane and 2-chlorobutane. Kindly follow. Coming for optical isomerism. Here you have to show very interest point I want to give here. So chain isomerism and optical isomerism always possible in all types of organic compound. So just I will give an idea. This will be often I will give in all compounds. See, just in order to show optical activity, what is the necessary condition? Asymmetric carbon atom. Asymmetric carbon atom. So take a carbon atom. Now put a 4 bond. Conventionally I am putting now hydrogen below. The next CH3. Next CH2, CH3. Then whatever functional group I will add here. In this case halogen, I am adding chlorine. So according to the IUPAC name, this is the longest chain. So numbering is 1, 2, 3, 4, 2-chlorobutane. That is, this is the example. Kindly follow. This is optically active. So in mirror image, it will form another one. Suppose this is plus, another mirror image will be minus. So what will be mirror image? The same way chlorine will be here, carbon attached here there. So top again CS2, CS3, bottom is hydrogen and this side is CS3. So this plus means this will be minus. These two are called enantiomers. Kindly follow. If there is asymmetric carbon atom is there, one or more, they can form enantiomer. What are enantiomers? Optically active compound having same molecular formula, but one will be the mirror image of the other. Kindly follow. So that means haloalkanes, in this case 2-chlorobutane, shows optical isomerism. Now let me come for the most important part, general method of preparation. What are the general method? We can prepare the alkyl halides, haloalkane. First one, order from alkane. I can say simply the name of the reaction is halogenation of alkane. Kindly follow. This is the general method. First general, in presence of light or catalyst, alkane undergo free radical halogenation with chlorine or bromine to give alkyl halide. Usually mixtures of halide will be produced. Kindly follow. So this is the general RCH3, chlorine in presence of light, RCH2Cl, HCl is formed. So specifically if I take methane, I am getting methyl chloride and HCl. Please follow. Suppose if I am taking ethane, again the same condition of light and chlorine, ethyl chloride and HCl. This general method you can apply for all halogen you can prepare. One problem is there, always a mixture of products will be formed. Kindly follow. Now, by this method, alkyl halides cannot be prepared by this method. Please note this one. Question can be asked. Alkyl iodide, that is Ri, cannot be prepared by this method because when you are treating iodine in presence of light, it is forming ethyl iodide and Hi, which is strong acid, that is undergo reversible reaction to produce ethane. That means once it is formed Hi, it will reduce again iodine to ethane. So alkyl iodide cannot be prepared by this general method. So in that case, we have followed a different method. The specific name of the reaction is called Fingelstein reaction. Please note, question can be asked. What is Fingelstein reaction? Please note now. So now we are coming the first name of the reaction. Fingelstein reaction. What is Fingelstein reactions? If you want to prepare any alkyl halides, kindly follow. Alkyl halides can be prepared from alkyl chloride on reaction with sodium iodide in presence of acetone. So any halide you can prepare easily, chloride, any chloride you can prepare easily. Then treat with the sodium iodide in presence of acetone. It produces the double decomposition like Ri and sodium chloride is formed. So this way now we can prepare corresponding methyl iodide, ethyl iodide, etc. But a simple way of doing by iodination we cannot prepare. The most important, so this reaction is called Fingelstein reaction. Conversion of chloride to iodide is called, in presence of acetone, Fingelstein reaction. Now, that is from alkane. Now, it's number 2. From alkenes, we can prepare by the action of HX. Action of HX. X can be chlorine, bromine, or iodine. Kindly follow. So normally we are using in the laboratory HBr or HCl or HI we are using. So alkenes undergo additional reaction with halogenated acids, that is HX, to form alkyl halides obeying Markovnikov rule or anti-Markovnikov rule or peroxide effect. So I have to explain these three. What is Markovnikov rule? What is anti-Markovnikov rule or peroxide effect? Let me explain. Kindly follow. So general reaction is given at the top. The first case, that is called obeying Markovnikov rule. This is obeying Markovnikov rule. Kindly follow. There are CH double bond CH2 HX when you add. So this is reactions undergoing through ionic and it is forming this. the corresponding X is going to second carbon atom. So specific example, 1 propene, kindly follow, 1 propene reacts with HBr. So what will happen now? Due to electromeric effect, this bond will break like this. So this will be plus, this will be minus. So negative will add to the positive. So we are getting 2-bromopropane according to Markovnik's rule. Kindly follow. The negative, what is Markovnik's rule? The negative part of the addendum goes to the carbon containing least number of hydrogen. So this is the least. Kindly follow. But Markovnik's rule fails in number of cases. That's why I have used the electromeric effect here. All these things I have discussed already under the basic concept of organic chemistry. Come for the other example, anti-Markovnik's rule or peroxide effect. In presence of peroxide, kindly follow, what is happening now? The reverse reaction. That is, so this is a general reaction. So this is specific. Same specific 1 propene, I am adding HBr. In presence of peroxide, I am getting 1 bromopropane. So what is the normal peroxide used for this? Perbenzoic acid. Kindly follow. So this is the acid used normally, perbenzoic acid. So when you heat strongly, it will break homolytically, producing OH radical and this radical. Kindly follow. So this OH radical will react with HBr, form water, Br radical. Then Br radical will attack, we have to go for the mechanism. That's why this is called Markovnik's anti-Markovnik's rule or peroxide effect. So one important information, kindly note, my dear student. In the Markovnik's rule, ionic mechanism is operating. In peroxide effect, there is free radical mechanism is operating. That is the only thing you must have. Kindly follow. So, from alcohols, so first alkene, then since we are halide we are preparing, I am taking the next order, alcohol. Alkyl halides are best prepared from alcohol by using different alkylating agent like HX, HCl, HBr, HI, then PX3 or PX5, or that is PCl3, PCl5, then thionyl chloride. Kindly follow. So this is the general reaction. ROH, HX gives simply forming water, RX and water is formed. So specific example, ethyl alcohol reacts with the HCl, 1 mole, ethyl chloride and water is produced. Kindly follow HX. So I can use instead of HX, I can use HBr, HI, like that I can use. Kindly follow. Now, let me concentrate on action of PCl3. Please follow, this is the type 2. Type 1 HX, type 2 PCl3. Whenever PCl3 is involved, what is happening? It is producing generally RX and phosphorus acid is formed. Correspondingly, H3PO3 it is formed. Kindly follow. This is the most important. So actually what is happening here? 3 molecules of ethyl alcohol reacts with PCl3, producing 3 molecules of ethyl chloride and H3PO3 is produced. This is the most important. Kindly follow. So phosphorus acid is formed. Whereas if you go for same alcohol, if you treat with phosphorus pentachloride, here additional to alkyl halide, phosphorus oxychloride is formed. Instead of phosphorus acid, phosphorus oxychloride and HCl is formed. So specific example, kindly follow. If you take ethyl alcohol, PCl5, ethyl chloride, phosphorus oxychloride and HCl is formed. So if you want, I will write, you can just see what way I will write. Just see here to understand this reaction. So I will write like this. So when I am writing here, I will write PCl3, Cl and again Cl, break the bond. So POCl3, phosphorus oxychloride, 2 moles of HCl. So automatically 2 HCl it is formed. Kindly follow. So again actually, so in this case automatically, so we are getting now ethyl chloride, phosphorus oxychloride, 2 moles of HCl. So the most important information here, action of phosphorus halide. So specific example, phosphorus trichloride or dibromide or diiodide corresponding halide and phosphorus acid. If it is phosphorus pentachloride, oxychloride is formed. Additional to halide and HCl. Please keep it in your mind. And another important third one, kindly follow, action of thionyl chloride. This is called pure method, most important method. Laboratory method, pure method. Alcohols undergo substitution reaction with thionyl chloride, SOCl2, to produce pure alkyl chloride. So this is the general formula, ROH, SOCl2 giving RCl, SO2, the SCl. So how you have just imagine, again I can imagine, I will write now the structure, H2OH. Kindly follow. So what I am writing here, yes, kindly follow, O, Cl here, Cl here. Kindly follow. What is happening now? Ethyl chloride, sulfur dioxide, HCl. That is the product form. Kindly follow. Easy way to understand now. So whenever you treat with the thionyl chloride, ethyl chloride, sulfur dioxide, HCl, so both are gases will escape into the atmosphere, leaving ethyl chloride in pure form. That's why it's called pure method. The next method of preparation is from silver salt of carboxylic acid. Kindly follow. That is action of halogen. Action of halogen. That is specifically bromine. In this case, action of bromine. A specific name is given for this Hunsticker reaction. Please remember the second name reaction you are hearing. One is Fingelstein reaction, this is Hunsticker reaction. What way? Chlorine or bromine will decompose silver salt of carboxylic acid to produce alkyl halide. If you use, so for example, in this case, I am using silver acetate. This general equation, it will take specific. Silver acetate, I am treating with bromine. So it is forming methyl bromide. Carbon dioxide is going out, and silver bromide it is formed. Kindly follow. So if you want to balance, what will happen? This is 2 here, this is 2Br is okay. Silver is okay, carbon dioxide. So we are getting methyl bromide, carbon dioxide, and silver bromide. Very, very important name reaction, Hunsticker reaction. Either bromine or chlorine you can use. Kindly follow. Another one, the most important is action of iodine. Again, from silver salt of carboxylic acid. Instead of bromine or chlorine, if you use iodine, the name is different. The name of the reaction is Binbaum-Simonini reaction. Third name reaction. Binbaum-Simonini reaction. Iodine will decompose silver salt of carboxylic acid to produce alkyl iodide. So instead of bromine or the chlorine, I am using iodine. Same acetate, kindly follow. So same silver acetate to iodine. So it is getting now silver, that is methyl acetate. Kindly follow. I am getting now ester. Kindly follow. So I am getting the ester, correspondingly carbon dioxide and silver iodide. Kindly follow this method. We are not using for, kindly follow, preparation of halide. Please follow. So what I want to give here, just to give idea about that. So only bromine, iodine, only giving corresponding halide. But if you use iodine, it is forming corresponding acetate, ester. So this we cannot apply, prepare for the corresponding halide. So kindly keep it in mind, Binbaum-Simonini reaction, just like Fingelstein reaction. Coming for properties. First, as usual, physical properties. Lower members are gases and higher members are liquids and solids. Alkyl halides are insoluble in water but soluble in organic solvent. They are toxic in nature. Boiling points are higher than hydrocarbon, corresponding hydrocarbon. Suppose you have ethane, one chloroethane will be higher boiling than ethane because of chlorine atom. Kindly follow. Coming for chemical properties, so I can classify the all chemical reaction into two subheading. One is substitution reaction, another is elimination reaction. Kindly follow. What is substitution reaction? What is elimination reaction? I have already discussed under the basic concept of chemistry, types of reaction and mechanism. Under the types of reaction, I have discussed in detail. So one is substitution, another is elimination. So let me take now the first one. Formation of hydrocarbon. That means we can prepare hydrocarbon from halide. What is the method? A. Reduction with zinc and HCl. Action of zinc and HCl. So alkyl halide undergo reduction by Nathan hydrogen on reaction of zinc with HCl to produce corresponding alkane. So zinc and HCl reacts to produce Nathan hydrogen, that will remove I, so producing corresponding alkane, general method. So specifically ethyl halide undergo reduction to give ethane and HI. Please follow. This is reduction with zinc and HCl. Now, under this, I have to give again hydrocarbon, but a famous reaction, Wood's reaction. What is Wood's reaction here is, that is higher members are prepared from that is higher number of hydrocarbons can be prepared from the lower number of halides. Or if it is the lower number of hydrocarbon, convert into halide and then convert into higher number. Kindly follow. Alkyl halides undergo Wood's reaction with metallic sodium in dry ether solvent to alkanes containing even number of carbon atom. Please keep it in mind. Even number, not odd number. 2, 4, 6, 8 like that. Odd number it is not suitable. So this is the general reaction. 2Rx plus 2Na, dry ether RR, 2Na. Specifically, I am taking 2 moles of methyl iodide to sodium. Dry ether, it is becoming ethane and NaI. So how you can imagine, just see what is this way, if you imagine, it will be useful for you. This is sodium plus iodine, methyl. So now use dry ether. So this way you imagine what will happen now. This automatically sodium iodide will be removed. The 2 methyl group will join. We are getting this ethane and sodium iodide. Please understand this. So Wood's reaction is most important reaction. So any even number you can prepare. Odd number you will get always a mixer. So I will inform you now. So Wood's reaction, it is suitable for the preparation of alkane containing even number of carbon atom 2, 4, 6, 8, etc. It fails, second, with the tertiary halides. Most important. Question can be asked, one among the following halide will not undergo Wood's reaction, tertiary halides will not undergo, because elimination is not possible. The coming for third one, the order of reactivity of alkyl halide, Ri is more reactive than RBr is more reactive than RCl. Please follow. Most important for Wood's reaction. So here I want to give one information. Suppose I want to prepare propane, odd number. What I have to use? Ethyl iodide plus 2 sodium plus methyl iodide. Kindly follow. In presence of dry ether. So when I am using dry ether, what will happen now? I am expecting 2 propane I am getting expected product. But what will happen when you mix these two? Kindly follow. Additionally, 2 moles of methyl iodide combines with sodium to produce butane. And 2 moles of methyl iodide combine to give, this is ethane. And here it is producing butane. Kindly follow. So, if you want to prepare propane, if you use ethyl iodide and methyl iodide, additional to propane, we are getting ethane and butane. So, these two you have to separate. So, normally we will not use Wood's reaction for the preparation of odd number of hydrocarbon. Carbon atom containing odd number. It is suitable only for preparation of alkane containing even number of carbon atom. Now, Wood's reaction we have seen. Now let me come for the third one, Woods-Fittig reaction. What is Woods-Fittig reaction? Very interesting. Alkyl halides undergo Woods-Fittig reaction with aryl halide, that we will be studying again under the aryl, to produce alkyl substituted aromatic hydrocarbon. General example, Rx plus 2Na 6H by X dry ether. We are getting 6H5R plus NaX. Specific example, methyl chloride, chlorobenzene, 2 moles. So what will happen now? Kindly follow. This is 2 chloride. So methyl group attached to benzene. This is called toluene. This is called toluene. So formula toluene is, this is the toluene. CH3, it is the toluene. CH3, C6H5. Kindly follow. So this reaction is called Woods-Fittig reaction. So Woods-Fittig reaction is useful to prepare alkyl organic compound. Alkyl, please follow. Means aromatic, alkyl means alkyl part. So toluene, ethyl benzene, propyl benzene, etc. we can prepare by this method. Then the another most important reaction D, Friedel-Graf reaction. Please follow. This is also important name reaction. Woods-Fittig, now Friedel-Graf reaction. Alkyl halides undergo Friedel-Graf reaction with aromatic hydrocarbon to produce alkyl substituted hydrocarbon, aromatic hydrocarbon, in presence of anhydrous aluminum chloride. Please follow. Rx plus C6H5X, anhydrous aluminum chloride produce C6H5R HX. So specific example, I am taking methyl chloride, I am taking chlorobenzene, kindly follow. And so now in this case, so what will happen now? I am treating, kindly follow, anhydrous aluminum chloride. So when you treat with, what will happen now? Kindly follow. Now this is no Friedel-Graf from the aromatic hydrocarbon. This is not chlorine, is not correct. It is C6H6. Please follow. Kindly do correction. Undergoes Friedel-Graf reaction with aromatic hydrocarbon. Please follow. Aromatic hydrocarbon. So, kindly follow. Benzene undergo reaction with methyl chloride in presence of anhydrous aluminum chloride. So, what will happen now? We are getting toluene plus HCl. Kindly follow. So this is called Friedel-Graf reaction. So alkyl halides undergo Friedel-Graf reaction with aromatic hydrocarbon. Suppose I want to put toluene, I can use methyl chloride. If I want ethyl benzene, I will use ethyl chloride. So depending upon this, I will change this reagent, alkyl part. So this is, but in presence of anhydrous aluminum chloride, that is Friedel-Graf reaction. Kindly follow. The next one, so far what we had is only preparation of alkane from halide. Now, let me go for, these are all substitution reaction we have seen so far, all substitution. Now coming for the formation of alkenes, that is coming under the elimination reaction. Kindly follow. Any alkyl halide generally react with alcoholic KOH to give alkenes by elimination of hydrogen halide. General formula RCH2CH2Cl, alcoholic KOH, producing alkene, RCH-CH2, potassium chloride with water. Specific example, 1-chloropropane on treatment with alcoholic potassium hydroxide, it is eliminating hydrogen from here, HCl from here, producing 1-propene, KCl plus water. Kindly follow. So, this is the elimination reaction. So, when this is the primary, kindly follow, primary propyl chloride. We know we have studied already primary, secondary and tertiary. So, let me give information here. Please note, my dear students. Under the mechanism we have discussed. That is E1, E2 mechanism, we have discussed this. Primary and secondary halides undergo E2 elimination. Tertiary halides undergo E1 elimination. E2 means a single step, Even means 2 steps through intermediate. If you want further information, kindly refer basic concept of organic chemistry under E1 and E2 mechanism. You will have a very clear idea. You can. So this is elimination. And again, the formation of alcohol, this is again a substitution reaction. Kindly follow. It is not elimination, it is substitution reaction. Kindly follow. Here we are not using alcohol, we are using aqueous potassium hydroxide. Alkyl halides undergo hydrolysis by aqueous potassium hydroxide or moist silver oxide to produce alcohol. General formula RCH2Cl, aqueous KOH, RCH2OH, KCl. Specific example, ethyl chloride, aqueous potassium hydroxide, ethyl alcohol and potassium chloride. So I can prepare methyl alcohol, methyl chloride, ethyl alcohol, ethyl chloride, propyl alcohol, propyl chloride. So whatever alcohol I need, I will use correspondingly. Kindly follow. So this is the from alcohol I can prepare halides. And thioalcohols, again remember, also we can prepare from halides. How? Alkyl halides undergo substitution reaction with alcoholic sodium hydrogen sulfide. Sodium hydrogen sulfide. That is to produce thioalcohol. Kindly follow, if it is OH, sodium hydroxide, this is hydrogen sulfide, sodium hydrogen sulfide bisulfide, simply we will call it as, to produce thioalcohol. So instead of OH, we are substituting SH. So ethyl iodide, when you treat with NaSH, so SH is substituted here, this is sodium iodide. This is called thioalcohol. Thioalcohol, or another name is mercaptan. Kindly follow. So thioalcohol, please follow. Then formation of ether. From halide, we can prepare ethers. The specific name is Williamson synthesis. Again, another name reaction, kindly noted this. Williamson synthesis. Alkyl halides undergo substitution reaction with sodium alkoxide to produce ether. What way? Sodium alkoxide, general RX, we are getting ROR, sodium X. Specific example, sodium ethoxide and ethyl iodide. Kindly follow. In presence of ether solvent, so we are getting now the corresponding sodium iodide is eliminated, so ether is formed. Diethyl ether is formed. So by using this one, we can prepare any ether you can prepare. Kindly follow. The most important information. This is called Williamson synthesis. That means preparation of ether from the sodium ethyl iodide in presence of sodium alkoxide, and ether will call it as Williamson synthesis. And next is formation of ester from alkyl halide. How? When an alkyl halide treated with an alcoholic solution of silver salt of carboxylic acid, an ester is formed. So this we have already discussed there. Kindly follow the previous case. That is, for example, RCOOAG or dash H giving RCOO or dash. This is the ester functional group AgX. So specific example, silver acetate reacts with the methyl iodide. Silver iodide is getting precipitated. Now we will getting methyl acetate. So ester is formed. So depending upon the requirement, we can prepare any ester with the help of suitable halide. So instead of methyl iodide, if I use ethyl iodide, I will get ethyl acetate. Kindly follow. Formation of amine, another most important reaction. Kindly follow. Formation of amine. When alkyl halides are treated with alcoholic solution of ammonia under pressure, a mixture of amines are produced. Mixture of amines are produced. So example, NH3RX, first one, RNH2, then RNH2 plus RX or RNH secondary, further RX tertiary, and further will go quaternary. So take a specific example, methyl iodide ammonia is giving methylamine and methyl iodide. So kindly follow now. In this case, the correspondingly here 2 moles of the methyl iodide and 1 mole of methylamine. Kindly follow. So what we are getting here, kindly follow this here. That is, we are getting the dimethylamine. What way? First one, methylamine is formed. Kindly follow. This is formed. Then second, again when you treat with methyl iodide, this H will be substituted by iodide. We are getting the dimethylamine. This is secondary. This is primary. Secondary. This is primary. And again, when you treat one more mole, it is giving tertiary. Trimethyl ammonia. 1 more mole of methyl iodide, it is tetramethyl ammonium iodide, quaternary salt. Quaternary salt. So, mixture of amines, it is formed under this case. So, by controlled addition of alkyl halide, you can stop at primary amine, secondary amine, tertiary amine, or excess quaternary salt. Kindly follow. The most important, another important is formation of cyanide, alkyl cyanide. When alkyl halides are treated with an aqueous alcoholic solution of KCN, potassium cyanide, the corresponding cyanide or nitriles are formed. Both are same. So general reaction Rx plus KCN gives RCN plus KX. So specific example, ethyl iodide react with potassium cyanide. So potassium iodide is going out, ethyl cyanide and potassium iodide. This is called propane nitrile, IPH name, or ethyl cyanide is the common name. Kindly follow. Now, another most important property, that is formation of Grignard reagent. This is a synthetic reagent. Please follow. This is the synthetic reagent. Using this synthetic reagent, we can prepare any organic compound. When alkyl halides are treated with magnesium powder in dry ether, kindly follow, to form magnesium alkyl halide known as Grignard reagent. This is the general formula. Rx plus Mg dry ether or MgX. So if we take ethyl iodide, magnesium dry ether, we are getting this ethyl magnesium iodide, or we can get another way also, methyl magnesium also we can. If you use methyl iodide, methyl magnesium iodide. If you use ethyl iodide, ethyl magnesium iodide. Normally this reagent will be available in the solution of ether solution. In the market, it is available only in ether solution. So this is a synthetic reagent, most important. So we have come to the conclusion, my dear students. So we have discussed the general, regarding classifications, naming, isomerism, preparation, properties we have discussed. Kindly follow. So I am coming to the conclusion. My dear students, the students who are looking for the first time in YouTube, my channel, Neat Chemistry by Neat Chemistry by Dr.R.G. I request you kindly click like, kindly click subscribe button to motivate me. Also, I want to give one information. I have started this channel in order to help poor people of India who are not able to go even for tuition. They can. For them, I want to give guidelines. So if any poor student, if you are going from 8th standard itself, I am taking the chapter. 8th, 9th, 10th chapters I have included in the basic unit 1. In basic unit 1, I have included 8th, 9th and 10th chapters I included. And hereafter, further plus 1 and plus 2 as usual. Kindly follow. So this is more suitable for poor student. Kindly go through. You do not go for tuition. So I want to give another information to students who are studying plus 1, plus 2 and plus 2 completed students who are waiting for this academic year NEET entrance examination conducted by Government of India. For you, I want to give some 3 important information. 1, we are running a coaching center at Vetri Coaching Center in Pondicherry for the last 21 years. And we are having our own site, website, vetri.s. Vetri namade in Tamil. Vetri.s. If you go in the home page, you can see our achievement for the last 20 years. From the beginning up to 21, all first rank in Pondicherry, even our students are taking, except 1 or 2 years. Our students are taking almost first rank. One. Second thing, every year minimum 10 to 20 students are joining JIPMER. 150 to 200 students are joining other medical colleges, common quota. And few students are joining IIT. And hundreds of students are joining other engineering college. That is our record, achievement. The most another achievement is, in 2003, one of our students, R. Srinivasa Raghavan, came All India first rank in JIPMER examination conducted by JIPMER. At that time, NEET and Common Entrance examination was not there. So this is our achievement in 2003 itself. Kindly follow, All India first rank. So, with this introduction, let me go further. The second feature of our Vetri.s. So, Vetri.s is containing 200 video lesson, 200 unit test. Please follow. 200 video lesson and 200 unit test. What is video lesson? So, there are 4 subjects: botany, zoology, physics, chemistry. So, each subject having 50 unit lesson, video lessons. All the lessons are taken by professors with PhD degree and having experience, 20 to 30 years of teaching experience for IIT and medical students, also BSc, MSc, MPhil and PhD students who are handling the classes. So what is the advantage of video lesson? You can see like your YouTube, any point you want to know, take notes, you just touch, it will stop, you take the notes, again touch, it will run. So this facility may not be available in other online coaching. The second most important is, we are having 200 unit tests. So for example, this is haloalkane and haloarenes. In this we have 2 tests, test 1 and test 2, each one having 45 questions. So all these 90 questions, actually test 1, test 2, totally 90, are taken from 20 years of previous question papers of IIT, AIMS, AFMC, Armed Medical College, AIPMT, MSET Andhra, Delhi, Karnataka, Kerala, Tamil Nadu, Pondicherry. So only these previous question papers are included in our unit test. What is the advantage we have now observing? For the last 6 years, by verifying the question papers of NEET, we observed 75-80 questions, same questions are appearing. Same question from our question bank is appearing. Because we are having 10,000 to 12,000 questions bank, full of previous question paper. So, the Vetri.s, if you attend all the 200 tests, you will get easily minimum 320. And if you are a good student, you can get 600 to 700. A dull student, even you can get 500 marks. Please follow. Now, coming for the unit test, I want to give one information. What is the unit test? If you go for unit test, there is a menu called attempt. If you click attempt, immediately the window will open. It will tell this unit contains 45 questions. Each question carries 4 marks. If one answer is correct, 4 marks awarded. One answer is wrong, -1 subtracted. Are you ready? If you say yes, click. If you click OK, immediately a window will open. You can see question number 1. You can see then the option A, option B, option C, option D will be there. And below that there are 3 options, the menu are there. And even below that, there is again here the 1 to 45 number will be there, question number. And here clock will run here. 45 minutes it will run. Kindly follow. So by looking this question number 1, if you observe A is the correct answer, click A. Immediately what is the wonder is happening now, you can see yourself, the question number 1 becoming yellow color changing to green color. The second question changing to blue color, second question, the number. And other numbers are yellow color. That means you have attended one question. After 20 questions, if you see these questions and questions, you can see 20 will be in green color. After 40, 40 will be in green color. So very easily you ask us which question you have attended, which question you have not attended. So not attended will be in yellow color. You click that question, you can answer. This convenience, please follow. This provision is not available in any leading coaching center. Any other leading coaching center of India. This facility is not available. So what is another facility? So after this, that is, I told you there are three menus. Center is complete. This is next. This is reverse. So next go for other question. Reverse go for reverse. And complete after finishing 45, you please complete. After complete, if you press complete, immediately what will happen now? Kindly follow. A window will open. A window will open. After, if you press complete, a window will open. In the window, you can see question number 1. Then option A, option B, option C, option D. And correct answer also will be given in yellow color. Correct answer in yellow color. There is below video solution. Please follow. And this is most important because how this you can get, there is a menu called review. So when you are pressing the mark, that is kindly follow the complete, when you press immediately you can see the marks, your mark. Say for example 160 by 180. That means you are losing 20 marks. So where you have done mistake and you can observe yourself. You can assess self-assessment, you can do yourself by using this. This facility is not available in any other online coaching. Please follow. What way you can assess? So question number 1, you are clicked already A, so it will be in blue color. So this will be correct, will be in yellow color. If both blue and yellow color will be same, your answer is correct. If both blue and yellow color is different, your answer is wrong. Easy. So you want to know about again. So this provision is not given in any other online leading coaching in India. This is our unique feature of Vettidatas. So self-assessment. Where you have done mistake, you can assess. Another thing. So if you do not know the answer, you need not go to any teacher or library or refer anything on teacher. Just below there is a solution, video solution. Just click that video solution. Video will run 10 to 15 minutes it will run. This is the most important characteristic of Vettidatas. Please follow. Most important characteristic of Vettidatas. How? Because the professor having PhD degree and handling the 20 to 30 years of experience will take this, will be standing in front of you on the board. Question will be there, option will be there. He will read the question and read the option, and he will explain on what topic or what subtopic this question is asked. What is the definition? What is the formula? What is the equation you have to apply? Everything he will explain. So it will take 10 to 15 minutes he will explain. If it is a problem, he will introduce the formulas, work out the problem. Everything he will do. So even a very, very dull student can easily understand this. So this facility is not available. If you go for any online coaching, they are giving solution. If you touch solution, you will get one word answer, one word, or one line or two lines. That's all. That's all. So only very, very brilliant student can understand. But the majority, 90% of students, you cannot understand the questions, problems. So, but Vettidatas will help you, so that if you join Vettidatas, 100% guarantee you will get 600 to 700 marks you can get out of 720. Please follow. So you can join in any college you want, either JIPMER or AIMS or Vellore or any other medical college nearer to your house. Kindly follow. So another most important thing, this is the low cost. We are charging only 10,000 rupees per year for all the subjects. Attending 200 tests, unit tests, 200 video lesson, and also doubt clearing also is there. Everything only 10,000 per year. How to pay? Pay 10,000 rupees in the name of Santi, Director, Vetti Coaching Center, Indian Bank number 71271 9471 is the account number. IFC code IDIB000P134. Cell number, any information or contact me, my phone number or WhatsApp number 98941 I hope I have come to the conclusion. Thank you very much for the kind cooperation. See you again in the next chapter. Bye bye.